Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Today I'm doing a little longer video than normal, which is why I didn't release it at 7 this morning. I'm releasing it as a premiere here in the afternoon. Now, once we're done with this, I'm going to go ahead and open up Discord, and we're probably going to broadcast that as well, because I thought it would be nice to get a group of us together to kind of discuss some of these concepts and maybe go over some more videos. Now today I'm going to have a look at a video on Nathan Oakley's channel where 10th Man talks about navigation. Now he is one of their fake experts on the sextant and navigation. But what I'm going to do is demonstrate how lack of scientific reasoning is leading him astray. So let's cue up the music and get going. Now I'm going to start off by going over this diagram that Nathan has up on his show right now. And I'm going to try and have a look at the diagram to see where their misunderstanding lies. So let's go ahead and have a look at the concept of a 90-degree angle on a curved surface. Now this seems to be something that they have an awful lot of trouble with. Now if you look at this purple line right here, this represents the curved surface of the Earth. Okay? It's an arc over the surface of the Earth. Now here is our observer location right here. Now you'll notice that he has a line marked, this dotted line that says surface level. Now that touches the curved surface of the Earth at one point, and that would be his location. Now notice that there is a straight line going directly above that point at a 90-degree angle to the surface level. The surface level is a tangent. Now it's a basic tenet of geometry that if you draw a line perpendicular to a tangent, you have a right angle. Now whether that tangent is located here or it's located at the horizon going straight up this way, there would be a tangent line going like so. You can draw a right angle there as well. And when you get down here to the target, notice that there's also a tangent line here, and this is a perpendicular line to that tangent as well. So there's a right angle between here and the surface at the location of that tangent line. Notice that there is a chord distance between the 2 points, and there's a distance along the surface of the Earth. The distance along the surface of the Earth is longer than the chord line. Notice too the Sagitta here, which is also called the versine. And by using the Sagitta or the versine, we can get an idea of the relationship between the chord line and the line across the surface of the Earth, which is an arc. Now this is why conspiracies in many cases are not a knowledge deficit problem. He has the information right in front of him. He's just not connecting the dots in his head to realize what that information is showing him. As we'll see, this is a very common problem in the Flat Earth conspiracy. So let's have a listen to Nathan and the 10th Man talk about navigation.
Nathan, I've got a few more slides on the topic that we left after the pre-show. Tell me when you're, I'm going to get to it myself.
Okay, I'm there. Great circle.
Yeah, give me a second. Hold on. There we go. Okay, so you've got, yeah, go to the bottom. Start from the bottom. New York to Paris.
Okay, ready when you are.
Yeah. So you want to go from New York to Paris in a straight line. It's 3625 miles. And the circular dotted line there is 3786 miles. But here they're a little trickery because the straight line is their curved line, and the curved line is the straight line. I'll explain. Next slide, please.
The shortest distance between any 2 points is what's called a great circle, and that's like stretching a string from New York to Paris. If you pull that string tight, this is the course that you will take. Now, the difference between this and what's called a Rumbline is that notice the angle the great circle course crosses this meridian. Now look at the angle here, and the angle here, and the angle here. Do you see how the angle changes? Now, with a Rumbline, you cross each meridian at exactly the same angle. Now, the difference between a great circle course, which is the shortest distance, and a Rumbline is one of convenience. With a Rumbline, you can set a compass course and follow that compass course all the way from New York to Paris, because it crosses each meridian at exactly the same angle. You'll notice the difference in distances. This is 3625, and this is 3786. So it's about 160 miles difference on an almost 4,000 mile journey. That's really not all that much if time is not of essence. And if you don't have the ability to calculate this course, it's much easier simply to follow the compass bearing. This is why the Mercator Map was developed. The Mercator Map was developed in such a way that you could draw a straight line from New York to Paris and it would cross each meridian at the same angle. It projected the spherical Earth onto a grid map, and by plotting a straight line on that grid map between 2 points, you plotted a Rumbline. To get the great circle route, you have to do something like the Haversine formula, and then you actually plot waypoints along the course that says, okay, well, I'm starting off on this compass bearing. In 100 miles, I'm going to change to this compass bearing. And that's the way you would follow a great circle course. And if you only had a compass for navigation, you could follow a great circle course by plotting out those waypoints and what your bearing would be from each of those waypoints. Now we just plot it out on the spherical GPS map, and it puts a little magenta line down on the surface of the Earth, and we just follow the magenta line. That keeps us right on the great circle course. Now right here is a really good example of not understanding the scientific concepts or the reasoning behind science. Now 10th Man has put up 2 slides so far. The first slide showed that a great circle distance is the shortest distance between any 2 points on Earth. It is shorter than a Rumbline. And then he goes and puts this slide up and says, okay, well, if you stretch a string across the surface of a sphere between 2 points, that's the shortest distance between those 2 points on a sphere, a great circle. He just got done saying that the shortest distance between 2 points on Earth is a great circle. He's not making the connection that if the shortest distance along the surface of the Earth is a great circle distance, the Earth by definition must be a sphere. Now you would have to add a caveat to that, and that is that the shortest distance at any location in any direction along the surface of the Earth is a great circle, which of course is the case. But do we really need to go into it that deeply when we've already identified the key issue in his reasoning? He doesn't connect the concept that the shortest distance between 2 points on Earth is a great circle and the shortest distance between 2 points on the surface of a sphere is a great circle. It's just going right over his head because he's trying to promote this narrative in his science denial conspiracy. Let's listen to some more. Now, first of all, the Rumbline is not a straight line. The great circle is a straight line. You've got it backwards. The Rumbline is a straight line only on a Mercator projection, but I do want you to have a look at this Rumbline. Look at where it crosses the up and down meridians. You see how that angle remains the same all the way along until it spirals into the pole? Now look at the great circle distance. Right here is very obvious. But if you look at the great circle distance and compare it to the lines of latitude, you see how they're different? You see how the angle here, it's coming up into that meridian, and here it's going down away from the meridian? That's the difference between a Rumbline and a great circle. The shortest distance between any 2 points on Earth, as well as on the surface of a sphere, is that great circle distance.
Their presupposed model, if you go southerly, you end up at the southern pole. That's their straight line. But the great circle, that's the shortest route. That's the curved line. Now notice the switcheroo here. All right, next slide, please. So what is a great circle? A great circle is anything. Now this is presuppose. It's all make-believe because you got to assume you're on the globe, and we just went through housekeeping. There's no R. We don't have any radius value. But if you were on the globe, a great circle would be this great circle with the yellow meeting the red, and it goes all the way through the center of the Earth.
You know, despite all of his rhetoric and his presupposed and no radius and everything, this is obviously testable. How could we test the idea that the great circle distance is the shortest distance between any 2 points on the Earth? Well, we can actually measure distances across the ground. Now, recently I had a trip from Florida to Michigan, and I calculated the distances between those 2 points, both on a flat plane using triangles and on a spherical surface using the Haversine formula. Now, I can actually measure the distance between those 2 points. And guess which distance it matches? The flat Earth distance? No. It matches the great circle distance. Now, the other thing that's very interesting is if you know the distance between those 2 points, you can actually calculate the Haversine, which doesn't involve the radius. That's just the angle of the arc. And you can use that to calculate what the radius of the Earth is. And I successfully calculated the radius of the Earth. Now that goes along with all the other ways that we have to calculate the radius of the Earth. The Eratosthenes experiment, Al-Biruni. We can even calculate the radius of the Earth based on how much weights change with latitude, because that has to do with the angular velocity of the rotation of the Earth. And the thing about science is that we have scientific concordance, and that means that even though we calculated the radius of the Earth by Eratosthenes, Al-Biruni, rotation of the Earth, and distance across the surface of the Earth, they all come back to the same radius. You know, they have a chant that you need R for that. Well, we have R, so I guess that solves that problem, eh? Now, the other thing that's very important about this is by using the great circle distance and the radius of the Earth, which we obtained by other means, we can calculate the distance between any 2 points. You can do the same thing on a flat Earth using triangles, connecting your starting point to the North Pole to your ending point. You can calculate that leg of that triangle. That doesn't match with the actual distance between those 2 points on the surface of the Earth. The great circle distance does. Now let me show you another problem that the flat Earth has. That line, the red line, is very clearly curved. That is the great circle distance between Santiago, Chile, and London in the United Kingdom. Now let's go ahead and rotate the Earth so that line is directly underneath us. That looks pretty straight to me. So here you go, flat earthers. Straight line, curved line, straight line, curved line. A basic inability to comprehend 3 dimensions. And this is something that you have to have in order to do science. You need to be able to visualize things in 3 dimensions. It's very clear from this example that they can't. They can't comprehend the concept that if you have a curved line on the curved surface of the Earth and you rotate that line so it's directly underneath you, that looks like it's straight. You move it off to the side a little bit, it's curved again. This is a foreign concept to them. This is yet another example of the illogical reasoning that conspiracy theorists and science deniers tend to use. I got on to Nathan Oakley's after show, and I specifically invited the 10th man to come join me today. He decided to decline in favor of calling me a name. But the invitation was there, and it was a polite invitation, and he could have sat down and discussed some of this stuff with me now, but he chose not to. Probably a wise decision on his part, because nobody likes to be made to look foolish. Now, if for some reason you think I'm being unfair with this, let's listen to him say it again. I don't think he understands the concept that when you put a great circle directly underneath you in the center of the earth, it appears to be a straight line. My assertion is that a great circle is the shortest distance between any 2 points on earth. If you are directly over that great circle, it will appear to be a straight line. If you are off-center to the great circle above the surface of the earth, it'll appear to be curved because it is indeed curved. It's following the curve of the earth, but when it's directly underneath you, it's only in one dimension, that vertical component, and you don't see it go left or right. But let's let him go through it one more time.
It shows the great circle is a straight line, and the Rumbline is the curved line. Now go figure how they can switcheroo every time they want this nonsense. Because what they're trying to say is that the great circle, the slide previous with the yellow dotted lines, a continuous circle is a straight line. So on the very next slide, they'll show that as a straight line. And the Rumbline, the actual straight line, is the curved line on the globe. What nonsense. You need R for that first.
Well, it's a good thing that we have our 10th man. But, you know, even if we didn't have R, the great circle would still be the shortest distance across the surface of the earth, because the earth is a sphere.
Getting right down to the nitty-gritty. It's not just we've been deceived. Here's the deception. It's here's how you've been deceived. I love it, 10th. You're getting right into this.
Oh, there's so much more. It's just getting through that. Like I said, the first thing was making sure I knew how the sextant worked, and that was going to be the kill-all of all kill-alls, because if it can't work on the curved surface, it's over there. But then how do they trick the navigators? How come people using the sextant can actually believe it is working on the curved surface? So that's the stuff I'm into now. And there's so much minutia there. I have to watch video after video. I've ordered 9 books from eBay on this subject that will be coming in the week. I have quite a library accumulating here on this. Eventually, within the next 2-3 years, every segment of this will be dissected.
Oh, dear. You know, 10th man, every single one of those books that you ordered, if you actually would read them, they'll tell you that the sextant works because the earth is a sphere and celestial objects are very distant, and as a result, their light arrives at earth in parallel. That's the only way that a sextant works. It doesn't work on a flat earth with a local sun. It just doesn't. But will you realize that? How many times do you have to be instructed? This is the problem that you run into when you deal with a flat earth and other conspiracy theories. They don't want to believe the evidence that's right in front of them. If they have a book that tells them that celestial navigation requires a spherical earth, they'll say that it's some sort of a plot, and they'll just buy another book. Well, when that book tells them the same thing, well, that's a conspiracy because 2 different authors are conspiring to mislead him. So he'll get a third one. Now it's going to be 3 authors. And it doesn't matter how many n+1s he goes to. He's going to get the same answer because it's the truth. That's the way celestial navigation works. It works on a spherical earth. It works on a rotating earth. It works on a spherical rotating earth with very distant celestial objects such as the sun and the stars. Reading another book or making another video or looking at another flat earth video is not going to change that, 10th man. Now you've already looked into the sextant a little bit, and we're going to have a look at your videos on the sextant because they're hilarious, because your misunderstanding of the sextant and celestial navigation borders on absurdity. And quite frankly, it is a little humorous. So we're going to go through those as well, because quite frankly, you and Brian's Logic and Mitch from Australia are my new hobby. This is Bob the Science Guy signing out from Northern Michigan. Thank you very much for your time. I hope this was somewhat enlightening, and if you have a moment, hit that like, subscribe, and ring the bell icon for my channel. Now, if you'd like to be a member of the channel or a Patreon or just support us occasionally with a PayPal donation, All that money goes to buying new equipment for the channel to bring better content. One example would be this marine sextant that we use to find noon sightings and learn a little bit about celestial navigation. So until next time, this is Bob the Science Guy signing out from Northern Michigan. Thank you again for stopping by, and I'll see you again soon.